Welcome everybody to another episode in season 6 of the JUXTCast. We'll do a few round of introductions. I'm Malcolm Sparks, CTO.
I am Henry Garner, Principal Engineer and Head of the AI chapter.
I'm Denis Lobanov, one of the software engineers here.
And I'm Joe Littlejohn. I work on the delivery side at JUXT.
Well, that's great. And we're doing a special episode, I think, on what we're calling our AI radar, which is something we've had in the works for quite a long time. Henry, you've kind of been the sort of primary instigator of this. So it's something that we did before with the closure technologies. We blatantly stole it from ThoughtWorks, and we thought that's a really good idea. We're going to do exactly the same thing. And we built some technology, and I think they were very, I think they saw it as kind of copying was a form of flattery. And so we kind of got away with it. And it's a very good format because it allows us to sort of divide up advice and sort of into really, is this something that we're really recommending and we've used before, and we can say, yeah, on our consulting projects, this works. So let's just kind of go through the kind of the idea of the radar then, Henry.
Sure. So yeah, this is an AI focused radar, which is obviously an extremely challenging thing to put together given the pace of change going on in AI right now. But the framework that the radar provides allows us to group everything that's going on into 4 key areas. We've got techniques, languages and frameworks, tools and platforms. And then within each of those sections, the things that we, as you say, are particularly bullish on, the things that we think people might like to trial or assess for their own use cases, and things that, on balance, we think people probably might like to avoid right now.
Yeah, and a lot of this comes from our kind of experience. Sometimes they're side projects, but often they're working actually on real customer sites and things that we can't really talk about in depth sometimes, but we can sort of say, well, actually, this technology is worth
exactly
exploring.
And that's the great thing about the AI chapter is that through that we can bring together the expertise that we are developing and focus on kind of knowledge sharing about the developments that are going on and some of the successes we're seeing in the abstract without going into details that allow us as an organization to develop greater expertise.
Yeah, well, I look forward to getting down into more of the details. So we started the first quadrant we call techniques. And so we'll just kind of assess a few of those, what stands out. We're going to publish this radar at some point in the future so that we won't be able to cover everything in this episode, but we'll just kind of, this is a lightning quick tour through, looking through some things that we're kind of that's standing out to us.
Sure. Well, I mean, at the very top, what I'm looking at the moment of our the adopt area of our techniques section is classical ML. Funnily enough, it is extraordinary what is going on in AI, and I've got a bunch of practical experience using LLMs and training them very effectively as classifiers, and there's no doubt that they are an absolute game changer when used in the context of those kind of standard approaches, if you like, with where a model is assigning labels to inputs. But there's still enormous value in traditional classifiers because they are much more efficient to deploy and train. Hosting them in production is cheaper. They go wrong in much more predictable ways. So, right out of the gates, I think we want to say that although I'm enormously excited about developments in AI, it's important that we remember that just because we happen to be holding an LLM hammer doesn't mean it's the right solution for every problem.
Not always the cheapest hammer to use.
Definitely not.
Cases.
No. But thinking about some of the interesting techniques where LLMs are very effective, we've got RAG. It's.
Do you want to expand what RAG is?
Sure. So it stands for Retrieval Augmented Generation, and it's a way of bringing into the model's context arbitrary external data. These models, whether you're fine-tuning or training your own models or using a foundation model, there's always going to be information that sits outside of the training data set that you might want the model to have access to at inference time. And RAG is a set of related approaches, really, for getting that information into the model's context, often by pulling it into the prompt. So that the question that you're asking of the LLM is then informed by your own business data, and there's a balance to be found between pulling in too much data and, again, spending too much money because you're burning through tokens, and too little where you're not providing the appropriate context to answer the business question.
Yeah. One pattern that I've seen here in this kind of space is that if you might be using an LLM to solve a problem that's traditionally solved by some other ML technique, and you can get incredible results sometimes from the LLM, and quite surprising that it can outperform a dedicated existing ML model or technique. But you mentioned the problem of unexpected failure cases. So sometimes you can be lulled a little bit into a false sense of securities. An example might be OCR. Let's say you might get fantastic results from an LLM that seem to outperform some other, traditional ML techniques. But then what you will get is a very unpredictable failure scenario where something is misunderstood that the traditional technique would be much more reliable in terms of, its repeated application.
Absolutely. And that can happen at multiple layers in the stack now that you're using vision models to interpret images, so that the possibility for noise to creep in and be interpreted as a signal by some layer in the stack and produce extraordinary results is definitely there. I've seen it in translating legal documents, for example, where an LLM, if presented with an Arabic document and it happens to be reading it in the wrong direction, will produce something that reads meaningfully, but of course has nothing to do with what's going on in that legal document.
Wow. Okay. So context is very important with RAG. I mean, RAG is a way of just giving the LLM some degree of local context. And the local context could be, will it rain today? Well, that kind of depends where you are.
Yes.
When you are.
So what you're saying there reminds me a bit of tool use, which is really another way in which LLMs are developing at the moment, where an LLM can make a call out to some external data at live via an API. But there are a host of different ways. Really, all that's required is that there's some kind of aspect of the prompt which can be interpreted as a query. And vector databases are commonly used, where you've got all of your business knowledge stored in a vector database. And essentially, you can look for how close each of the documents sitting in that database are to your query, and use that as a basis for figuring out which of the documents are likely to answer that.
So it's a good kind of guess to just gather all of the relevant document. How do you say what's relevant? Well, in a vector database, things that are relevant are closer to you in the vector space.
Yes, that's right. And of course, there's a whole different array of distance measures that you could use. And this is where really looking at how well a system is performing and tuning all of these decisions that you have to make is really important, because they are highly context dependent. But once you've identified a set of documents that might be of interest, one of the other things in the radar is cross-encoder re-ranking. So you probably want to know which are the most important documents. So you might bring back 100. You might say, trying to stuff my prompt with 100, the contents of 100 documents is going to be too much. It's going to cost too much. It's going to confuse the LLM. There might be too much information there. And so there are various strategies that you can employ for trying to identify which are the needles in the haystack, really. Because we're all context engineers now. Like we were prompt engineers. I think we are beginning to move away from prompts, because as I say, with tooling and other more intricate ways of stitching together systems, agentic systems, for example, where you might have LLMs communicating with each other, it's somewhat less about the prompt, which implies this kind of, I ask a question and I get a response, and more about managing the context that's flowing through the system.
Yeah. I seem to sort of think of the context as being one important parameter of the calculation, and that without the good local context, so a lot of questions are asked given this set of circumstances, then what do you think? So you can have a very kind of intelligent LLM on the surface, but without actually given the prior variables in the state of the world, then there's something missing. And it's really about getting the right data at the right time. But it's a very difficult data engineering problem, because most organizations have data everywhere. Access control is kind of on a system by system basis, but if you want to do it globally and you want to answer a big question across all of your departments, that's a lot of retrieval that's going to go on. And then the more data that you're kind of gathering together, that makes the kind of encoding, the judging which data is relevant, a difficult thing at scale. And context windows are, the more of a context window and more of a prompt you use, it's a kind of a law of diminishing returns somewhat, that even though Google and others have these vast context windows, it's not that you get the same performance if you use up a whole context window. Is that right? Or
well, I mean, a point that you made there was about really sort of AI readiness and having the right data infrastructure to support any AI use cases you might want to apply. And, it's true, if you are operating in a very siloed way, lots of pockets of data, you're going to miss out on some of the extraordinary value that AI is going to offer. And you're probably better off starting a bit further down the stack and sorting out your data estate.
So where do you stand on people writing passwords in their Excel sheets? Is that a good thing or a bad thing?
It's probably quite a bad thing.
It's definitely in the hold category.
Yeah.
As long as you change the formatting so it's only it doesn't show the characters, I think it's completely safe.
Well, if it's a white font on a white, I agree. Well, anyway.
That question of context windows, it still seems very much we're talking about a one-shot exercise often, like systems doing a lot of work, like RAG is a good example to expand the amount of data that's going along with a single prompt, but it's very much still a one-shot exercise. And I'm wondering if you're starting to come across techniques which are more about building up and influencing that base knowledge, which I know is difficult to do because at the moment, of course, it's very costly and time consuming to retrain an LLM or to adjust those weights. It's quite a costly exercise. So, but there does seem to be to some extent, the features of the LLM's chat interfaces that we're commonly interacting with, they're starting to build up features that allow more about the ongoing conversation to be remembered. Now, they're probably implemented at the moment by some kind of RAG-like technique where really this context is being included again within the context window of the next prompt.
Yep.
I just wondered if you've seen anything, Henry, that is starting to get into those realms of modifying or expanding the base knowledge within the model.
It's a very interesting question, but I want to start by caveating slightly what you said about it being very expensive to train a model. It used to be, and certainly if you're trying to retrain the entirety of a 500 billion parameter transformer model, that is going to set you back a few million. But if you use a smaller model, maybe with mere tens of billions of parameters, but you apply quantization and you use something like LoRa, which is mentioned in the radar, low rank adaptation, where you're really only retraining a portion of the model on your data. Then the costs are measured in thousands, rather than, maybe not even tens of thousands. You'd, of course, need to start with an open weight model, something like Llama or Mistral's offerings. But if you are quantizing, and so the model is the weights are stored as 8-bit integers rather than floats or doubles, then it can actually be pretty inexpensive to have your very own GPT that you're self-hosting, and that can save a huge amount of cost because thereafter you're not paying for pay per API requests. You're hosting something for yourself. But to come back to your question about kind of expanding the prompts as you go, I mean, it's making me think of reasoning models, which I don't think was quite what you had in mind. But when you look at how the reasoning models work, there are special tags, right, that are platform specific. It might be a little thinking tag that signals to the interface sitting behind OpenAI or Claude's interface that some thinking's going on, but the model is just outputting. There's nothing special about those thinking tokens. It's just you've got a delimiter essentially that says, okay, we're moving into a particular kind of operation here, and it's purely because those reasoning models have been trained on chains of thought. So it's about how those models have been trained so that they are just set up not to provide that single answer to your initial prompt, but to go off on a more kind of exploratory, discursive journey. And that's all in the training data and the training regime. And as I say, there's nothing magic about those thinking tokens, and they can be using tools, they can be doing web search, they can be. One of the things that I'm really fascinated about, and I'm watching quite closely, is how LLMs can be integrating with programming languages live and writing little tools for themselves, maybe in Prolog if you need logical inference, or maybe just in Python if it needs to do something on the fly, writing little tools for itself that can then provide that extra information into the context that then inform a subsequent response.
Yeah, it's kind of a similar way, or it's an alternative way of continuing to expand the body of knowledge as you're going effectively, but it just happens to be that the LLM is reaching out to a tool to answer a question, to work that knowledge into its answer.
Exactly. And that kind of machine translation is what LLMs are really good at. They're not great, even the reasoning models, at genuine reasoning. Yeah. It's we used to call them kind of approximate retrieval models, and the reasoning models are kind of approximate reasoning models. But if they are able to call out to external tools that can that have different characteristics, like a calculator, I think you mentioned, very well-defined behaviors, then the LLM can kind of sidestep the challenges that they have. For example,
it can bring predictability back to certain things in a way that where you expect predictability,
whilst using the LLM for what it's good at, which is taking some semantic structure and mapping it to a slightly different one.
Yeah, these failure modes that we've talked about, these unexpected failure modes, and another thing on the radar that you have is using the LLM as judge to validate output and understand whether it's accuracy or looking for these kind of failure modes. Do you think there's a limit to this? It does, as you say, it's counterintuitive to think, okay, well, this is the way to solve the problem, is to use another AI to validate what I'm being told. But it does seem like, interestingly, and this was something really striking from the talk that you did at XT25, is that there are scenarios where the LLM can be a better judge of accuracy and output than even human assessors.
Yes. So when I was working at a RegTech startup, I was CTO, we were building a classifier that was applying really quite complicated taxonomies about legal areas and regulatory areas like anti-money laundering or data protection to regulatory documents. And we had very skilled annotators of that data. They were, we called them reg analysts. They had not just regulatory experience, but legal expertise, and they would painstakingly go through documents applying tags, page by page, section by section, and these taxonomies could be hundreds of tags in size. And we captured training data from them that we could fine tune an LLM that did in fact perform. I want to be careful. What we found was that where the human analysts and the LLM disagreed, where maybe the LLM applied a tag that an analyst had missed to a document, an unseen document that wasn't in the training data, we found that the odds were greater than 50%. In fact, they were around 60% that the LLM was correct, and the same in reverse. So the LLM was in those areas of difference more likely to be right than the annotator. So it's part of why I know that these models are a real paradigm shift. Because we'd been working on, as you can imagine, it's the business of the company. We've been really trying to juice classifiers for many years to perform as well as we possibly could, and they didn't come close to what a fine-tuned LLM did on exactly the same data.
I guess in that case, the LLM has a benefit that it never gets bored, and it has an endless attention span. So, it's not going to get fatigued in its classification that a human might. I mean, obviously, exactly. You're speculating about why the differences are there. But
you mentioned, about well, at least what I heard in your question reminded me a little of some of the ways in which LLMs benefit from collaborating, and that when you do just ask an LLM to respond, there's some really interesting research from Anthropic, and the example I cited in the talk was the one where LLMs were trying to get Claude Haiku to respond to a harmful request, and they do that by encoding their harmful request, which in their example was making a bomb, into a kind of word game where the LLM had to take the first letter of several words and stitch them together, and then tell the human how to make one. And what the researchers found is that the LLM, more often than not, more than half the time, it would begin to comply, and that's because what's going on inside these models is so complicated that all of the training that Anthropic had done to prevent exactly this scenario from happening was registering inside the LLM. They could see that by looking at the activations going on in the features and circuits of the LLM, but it was outweighed by what the LLM desperately wanted to do, which was complete a grammatical sentence from start to end. And that's because that happens in all of the training data, at least the vast majority of it that it's ever seen is, I start a thought and I finish it. Because the text that it's been exposed to does exactly that. It doesn't suddenly pivot in the middle and go, hang on a second, no, I can't tell you how to do that. That's against my my values. And so this is why some of the agentic approaches, or LLM as a judge, where you have another LLM observing what's going on, it seems kind of counterintuitive because you're sort of funneling all of that rich stuff that's going on inside the transformer architecture through a text interface, one token at a time, to another transformer model, which is then spanning it out. But it can be valuable because that other model just sees the output that's being produced. It's not confused by all the other things that might be competing for what that next token might be within the source LLM. And it's why a sort of LLM is a judge. And indeed, some of the agentic setups, I think, are actually pretty valuable, although on the face of it, they appear to be just exacerbating some of the problems with LLMs and this sort of autoregressive one token at a time approach.
It's sort of similar in a way to a social engineering attack, really, isn't it? That
yes.
That relies on the fact that people generally like to be polite, and they might find it difficult to abruptly end a conversation or feel like they're going to be rude. In the same way, the LLM is subject to some constraints that it's built up by looking at the source data, that it's feeling an urge to follow those patterns, and it's similar to that kind of social engineering.
I love that analogy. Yes.
Holding the door open to the imposter.
Yes. Yeah.
Okay, well, that's on our techniques. Now we're going to have to move swiftly on to languages and frameworks. Now we've got a few in that you've caught your eye, Henry. We've got PyTorch, DBT, and Anthropic's kind of now gaining popularity. The MCP, Model Context Protocol. So do you want to touch on kind of why those have been particularly chosen? Why PyTorch?
Well, I mean, it is emerging as the de facto standard for training these large language models. It's got an enormous ecosystem of libraries. At the moment, at least, that is the one to back if you're investing significantly in any kind of AI or machine learning, kind of nuts and bolts development. It's where all the action's happening right now.
Yeah, and in particular, we're putting TensorFlow and some of the forerunners kind of a little bit to bed.
Exactly, not because they're not being used, but just they're not as actively developed anymore, and you are likely to start to see support fade away.
Yeah, and this is definitely an area where you want to be kind of on the front line,
Exactly.
on the front of the curve. DBT?
Well, I'm sure we've all worked in places where there are magical SQL statements floating around the business, data manipulation going on in a slightly sort of ad hoc way. DBT, I mean, there's this sort of open source tool and a cloud offering, but really what they're both geared towards is trying to put data engineering, data transformation, the T in ETL into bringing software engineering best practice.
So it's a bit like our, software developers, and I think a lot of our audience will be kind of with this analogy, but bringing in testing and CI/CD pipelines. Precisely. And that sort of predictability. So it's kind of allowing the machine learning or the AI community to sort of catch up with kind of what we take for granted now.
Indeed, and as we've already kind of touched on, getting your foundational data estate and architecture on a good footing is almost a prerequisite for getting the most out of AI, and DBT is one of the tools that can help you do that.
Perfect. Okay. Any thoughts, Dennis, on MCP and servers and clients? Do you want to just explain what MCP is, sort of where it came from, and what it's used for?
Sure. So yeah, I'm kind of probably in many ways reiterate what Henry already said, where it is the one to back. It's emerging as a de facto standard. So this is it's kind of aligning with all of the stuff now around tool calling and functions. So where you have your LLM maybe perform some sort of task and you want it to then interact with another system. So this might be as a way to say, okay, once you've done something, or you need to get some additional data, some additional context, something else.
Like the time or the weather, or
the time or the weather, yeah. Or, more realistically, get something from your specific business domain, maybe interact with another system, because this has now been integrated to a larger overall design.
Like query a database?
Potentially, that's the classic one. Though, yeah. So it's essentially a structured way to allow a model to call another system, where the call doesn't go from the LLM itself, but rather from whatever is the client that's calling the LLM. So you have some specific structured syntax that the LLM can use to return and say, this is what I want you to pump into this other system. And as long as that syntax all matches, you can now start integrating this kind of as another block, as another service in a larger architecture.
How does it differ from, say, OpenAPI, which is a very common way of describing an API, a very common way to enumerate all of its features and functions and documentation? So, there might be documentation strings and human readable or LLM readable documentation within the OpenAPI spec as well. How would you contrast the two?
OpenAPI is a lot more flexible. Like you can define a huge variety of different interfaces, and really the whole point is to provide that general approach for flexibly specifying what your API does. Whereas, as you've said, Dennis, the MCP is a much more constrained situation by design. We just want to be able to do prompts and tools and resources. And it's also it's kind of client server one-to-one stateful API, and I don't think there's any reason in principle that you couldn't define such an API through the Open API spec, but there will be a whole load of the spec that you never go near if that's all you're doing. And we've seen tens of thousands, was it 60,000 or more, like MCP servers? Some extraordinary number have been created really quickly. And I guess that's partly testament to the fact that it's really simple to set up a basic MCP server.
Yeah, it has essentially a lower barrier to entry, both from the engineers doing this work to figure out how we're going to integrate it. And it also has a certain amount of, it's apart from easier to reason with, it's also maybe some ways easier to secure, because if you have, if you're thinking of like, I'm going to now put some sort of LLM integration into a larger part of the business where, depending on what that other system is, if it's just data retrieval, that's fine, that you might want to check. If it's doing something else, and if there's side effects to that actual query coming in, you might want to start considering, how do I constrain what exactly it does? And since probably that LLM call is going to originate from some other system somewhere, from a user action, you might on a macro level say, well, whilst overall the system might be allowed to do certain things for this particular user, it should only be a subset. So the more you limit your permutations of what every component can do, and the simpler the overall architecture of any one thing is. So the simpler this, essentially the less that the model can do, the more constrained that this kind of approach is, the easier it is to figure out what's likely to happen and how I can limit what can happen.
So it almost feels like it's in tension between RAG and structured RAG, and in a way that those things are a kind of a batch mentality of, let's just find every last piece of evidence and sort of gather it all together and then give it in one big batch to the LLM. This is almost a bit more real time. It's allowing the LLM to kind of say, oh, no, I'd really like to know what the weather is in Los Angeles today. Now I'm going to ask that. And that might be the sensitive thing that you want to say, well, we're not going to let you know. Or so you kind of allow, it's a different approach really, but they seem to be in kind of healthy tension with each other, that you have this, perhaps, in some circumstances, it's just better and cheaper to just gather all the information up front, like in your kind of compliance documents and so on. But sometimes these tools just make all the difference.
Yeah.
I mean, it's tempting to imagine that a RAG system is always going to be like a dragnet, just fetching all of the similar documents, but it doesn't have to be that way. Like one of the things mentioned in the radar is structured RAG. That really all that's required from RAG is that there is something about the query that matches some number of external resources that might be useful to bring back into the context. There could be one document. There's nothing about RAG that says it has to be searching your entire knowledge base and pulling back everything that might be relevant.
Yeah, absolutely. So we'll go on to the third, the tools. We covered this? No. So we're really talking about here, well, first of all, the software engineering copilots that we're kind of using. How widespread are those, and what are people using when they're doing code? I know we've been playing around in the AI dev chapter with Claude Code.
Claude Code's been our fan favorite so far. What a time to be a software engineer, frankly. Like, I know AI is touching pretty much all of knowledge work in one way or another. Being a software engineer specifically, though, or really working in technology more generally, is amazing to see how these tools are and the emerging approaches, right? Because it's one of the things that I touched on in my talk, really, is that we're driving these systems with a blinking cursor chat interface for the most part, and yet there are a whole load of research papers which are being produced about the impact on developer productivity, on speed, on bugs by using AI, and the results are all over the map. The recent paper by METR, the Model Evaluation Threat Research, said actually for experienced developers on large code bases, although those developers thought they were 20% faster, they were actually 20% slower using AI. And there are so many different kind of analyses that I think what the picture that I'm getting is that the benefit that you realize from using these tools is highly context dependent. It's highly dependent on what kind of code base you're working in, what kind of language, your experience, how familiar with the code you are, and also definitely how sophisticated you are at wielding these tools. Because, there's nothing to stop you just, vibe coding your way through your entire code base. It's a bit like hopping on a 1000cc sports bike and just going, you're going to get hurt. But being a lot more cautious around your use, a lot more kind of judicious, and making sure you continue to stay in control. We've seen it. I'm convinced that it's a force for good in software development. Absolutely. But as I say, I think a lot of the benefit comes from learning how to be diligent about making sure that you are working in small, tight feedback loops. You are, planning as far as possible ahead of time. And although Claude Code is the one that we've been using, and it has a planning mode, this week or late last week, I think, AWS's Kiro IDE was announced. It's another VS Code fork. And what I'm really interested about that, and the reason I want to look at it very soon, is because it's starting to be opinionated about how you go about developing your code. It's got a vibe coding interface, but it's also got a specs approach, which will provide kind of guardrails for you and say, we're not going to jump straight to implementation. Tooling is starting to enforce that. The LLM isn't, let you do whatever you want, but the IDE is saying we're going to start by understanding what it is we're trying to do. We're going to start to design what that should look like. We're going to have an implementation plan. And this is fascinating to me because it seems to be taking away flexibility. But as we've often observed in technology, actually, constraints can be really useful, like the sort of go-to considered harmful kind of thing that pops up again and again in different contexts. So there are a huge number of these co-pilots, but I am looking to see how these interfaces begin to coalesce around a slightly less chat-based interface and a slightly more formalized interface that can be used not just for writing code, but planning, requirements gathering, even product ideation, maybe the whole software development lifecycle.
One thing that I've heard quite a few times actually is people describing working with one of these agentic AI workspaces or a tool that's going to help you with building things. They would describe it as having like a junior engineer that they're working with, someone that's like a junior engineer that's constantly raring to go off and change loads of things and having to kind of, rein that in and keep it under control. But it's interesting that in a way, what you're talking about is the flipping of that relationship where the user of the tool, the human, is actually receiving some more steady guidance from the LLM about not just what they should be doing, but also some quite seasoned guidance on the approach that, how they're going to approach this and things like that.
Yeah, that's a really interesting point. I mean, the way that I think of these tools is that they are reasoning partners. And what I'm suspicious of is when you say to the LLM, go off and do it, and they will enthusiastically go off and do it, whatever that means for them. You might not like the results. And yet, I don't necessarily have the answer. I don't know exactly maybe I'm not clear in my own mind about exactly what we're trying to achieve here. And flipping in a useful way, maintaining control is really the key thing here, really, because there have been other studies about the developer productivity using AI that have noted that users can experience a kind of inversion of control in an unhelpful way, where they lose that situational awareness. They don't understand the context in which they're operating. They're just reviewing AI outputs, but increasingly they're not quite sure how to review the AI outputs because the code base is starting to drift from what they've got in their heads. But there was a study to do with AI investment decision making. So this isn't software engineering, but I think the insight carries across where if investors articulated their own investment thesis first and then said to the AI, where are my blind spots? What kind of feedback would you offer me? What kind of companies should I be thinking about if this is my thesis? They got so much better results, and it was a study which formally showed that the satisfaction with those investments over time was something like 20 percentage points higher, because you're using the AI as this sort of co-intelligence, and you are in a way asking each other questions.
One thing that concern I have with the engineering co-pilots is that they do some of them have quite significant costs associated with them. I'm very concerned about the impact of this on open source software. It's kind of ironic, really, because a lot of these big, businesses that are based on training these huge models could not exist without this sort of huge sort of history of open source software. And it would be a big concern if people start not really being able to have open source projects that continue at the same rate as commercial projects, because they actually need to spend significant amounts on the AI assistance. And it's an appeal, really. I would really love to see some of the big model providers and the providers of these tools giving, some credit, free credit to open source software developers in a similar way to things like, profile vendors like YourKit and others are available, that they will give free licenses to significant open source projects. And, it's beneficial to them because they like their tools to be used. But if you're running a big open source project, you can often get people, some support from vendors in that way. And I would love to see for open source engineering some free credits, really, to make sure that those projects they don't fall behind, or they don't start to have a big cost in trying to continue development.
Yeah, I mean, I think it's quite also a boon on the good side for open source development, because it allows people who wouldn't ordinarily make a change to an open source project. You've got the fact it's open source, it's probably part of the training data anyway, but you've got the ability for the AI to act as a sort of Sherpa, as a guide, to say, well, and there's no guarantee that your PR is going to be accepted, but it allows you to sort of start writing in the style of the code base, particularly smaller open source projects. So maybe you can do some kind of good first issues, or it's that kind of help to get started. And I'm often looking at these kind of partnership with LLMs to sort of help you. LLMs are very good at domain knowledge and sort of to go deep and to sort of and broad and kind of prepare the ground for you and teach you how to, you could ask it, well, how do I get started on this OpenSSH patch that I want to write? Or, and it can really help in that kind of planning and education, because all open sources really are kind of an education gateway for people to learn and to go slightly deeper into a piece of technology.
But actually, speaking of opening that first PR on an open source project and version of control, one of the most useful areas where I found for LLMs in coding, and it kind of didn't start off this way. Initially, it was actually kind of chaotic, and this is having automated PR reviews. So at first, this was quite a, you have your first few reviews and you think, well, okay, maybe this comment summary is good, and everything else you're thinking, yeah, this is possibly not the greatest suggestion. However, how can I put it? My judgment of this completely changed after I saw, apart from some tuning, but also this applied to more junior members within the team. And whilst a lot of the stuff that might be suggested, you think, well, no, I made this decision specifically, or this kind of thing, it doesn't even apply. But actually, it sets a lower benchmark, and that benchmark, whilst to maybe your more senior engineers, it's just not going to apply. But once you have someone really new to the industry start in, actually, it's for me, this has been really quite a substantial boon to productivity, because it's now, unless you've matched that benchmark, I'm not going to bother reviewing. And unless you either match it or any other comments you're willing to dismiss, but you've consciously dismissed them, it actually sets a bottom mark, like a benchmark. So it's kind of helpful.
Yeah, it's sort of really good to be educated about some of these things until such time as you've got more knowledge and you can decide when to break the rules effectively.
Pretty much. Yeah. Of course, that depends on how well your PR review system is set up, because sometimes, and that obviously depends on the context and the prompts and everything else, because it can occasionally go off into the woods. But actually, surprisingly can be helpful.
Yeah.
You mentioned costs as well, Joe, and that's just one of the areas that is coming down really quickly. And so, although you're absolutely right, and I too would like to make sure that open source doesn't fall behind. I'm sort of staggered at how fast we're getting equivalent performance against standard benchmarks out of much smaller models, as the kind of distillation approach where larger models are kind of the functionality is replicated by smaller models through sort of iterative training processes, and of course the efficiency of hosting these things and running them, and edge compute. So increasingly we're going to start seeing those kind of models running to a similar kind of performance on our own devices. So we might start to see that we're getting that kind of performance and not even paying per token as we are currently.
Yeah, the beginning of the Moore's law path of
exactly,
improvement. Yeah.
Yes.
Quantization. There's the number of cheap. Of course, the chips are all increasing in power, but it means that you've got a secondary market for like chips that are then kind of past their sell-by date, but they're very useful for kind of inference engines and so on, and running locally.
Yeah, I've seen some hardware manufacturers. I think Framework is one of NVIDIA's one. I think Framework is another that they're starting to have consumer units coming on the market that are really just a box with a huge amount of VRAM that are kind of dedicated, not inexpensive, and are going to be dedicated to running a local model.
Very good. So last quadrant, platforms.
Yes.
So do you want to introduce that, Henry? What are platforms?
What are platforms? Well, I mean, this isn't an AI specific concept, but what we're saying here is there are a bunch of SaaS tools of which the hosted models are an example, the foundational models, which you might want to consider using. And indeed, foundational models are in the adopt section of the platforms. And that was one of the more challenging sections to fill out for this radar, because what we wanted to do was provide a kind of overview of the strengths and weaknesses of the offerings from all of the big players, of which there are at least 10, and the pace of change is so extreme that it's challenging to sort of tease out what might be invariant over even just a few months, really, as new models are rushed to market.
Is there any kind of foundation models that we would put? It's still an open horse race, isn't it? There's still many horses in this race, and it's quite difficult to predict. How are Anthropic doing? I mean, we use that and Claude Code. In terms of are they going to survive in a crowded marketplace? Are there kind of front runners that have really got the spend? I was watching a Bloomberg report on Stargate, which was this place in Texas where they're building an enormous, I think, 880,000 in GPU center going over many buildings, and presumably lots of cheap Texas energy and solar panels and so on. So at what point does it become who's got the deepest pockets, or do you see it's not that simple a metric? Does it become a kind of...
I mean, yeah, I don't think it can be that simple. I mean, you've got the open weights models in the mix now as well. So it's not just about the big providers hiding behind an API. There are Meta, DeepSeek, Quen, for example, producing models that are really good, that if you've got the hardware, you can run locally. Anthropic's heavily invested in by AWS, right? Amazon. OpenAI is obviously Microsoft. I think they've put in about $13 billion into OpenAI. Really interesting. I can't predict how OpenAI is going to develop. It's gone a little bit quiet at the moment. Things have lulled. We're awaiting the release of their next reasoning model. They had that slightly odd announcement with buying Johnny Ive's design company. So it suggests that they may be thinking very carefully about consumer design and how to build consumer tooling. but they have also announced a minimum spend $10 million consulting arm. So maybe they're trying to compete with the likes of Palantir, perhaps. It remains to be seen, really. I think they're sort of exploring business models.
Well, I remember in the 80s with the home computers, there was so much competition between the BBC and the Commodores and the Sinclairs of the world. It was actually a very exciting decade because the pace of change was just sped by that kind of healthy competition that the different companies had. So it does feel a little bit more healthy that you have lots and lots of different horses in this race still, rather than just one or two maybe players like we have, Windows and Mac, or Android and iPhone. It's kind of perhaps, or in terms of browsers as well. It's a kind of is a concern when you just have one or two big players.
Yeah, and it's globally distributed as well. Not all in the US or China. We've got Mistral in Europe, so in France, and actually, although they are relative minnows compared to everyone else on our list, I think, looking at it, they are very efficient models. If you are self-hosting and you are fine-tuning your own models, taking a look at Mistral's open weights models is a really good place to start.
Well, that's very good. Well, that was a great tour through the four quadrants, and looking forward to kind of us publishing that and engaging to more discussion. Obviously, in such a fast-moving area as AI, we are hoping to do this on a kind of regular basis, so at least update and indicate where we feel the change is happening, where there are different players emerging, lots of new things happening, and when we're seeing things change.
Yeah, for sure. It's something to be fed and watered.
Okay, well, thank you very much for everybody on the podcast. It was a really nice conversation. Look out for JUXT's AI radar coming out soon, and looking forward to seeing you on another podcast. Thanks very much.
Thanks all.
Thank you.
Thank you.